In the second step, we will try to inject the code while at process. So in the previous task, we modified the initial .shell file to get our injected program to run automatically. And with the root privilege, this initialized script file is used by the underlying Linux operating system. Once the Linux part is initialed, Android OS will bootstrap its running runtime that is built on top of it of Linux. We would like to execute our inject program during this bootstrapping process. The object of this task is not only find a different way to do what we have done in the previous task, but also learn how Android gets bootstrapped. So here, like the previous step, in order to put code, running the code into the Android OS, we have to using the OTA package, OTA over the air package again. We have to follow the exact folder structure of OTA. Let me create the same folder structure. After we have successfully created the, the path, the folder, we can see it from PWD. And now we need to add all kinds of code inside. So first of all, we have to build an app process. App process is not like a Java file. It is not also not a .c file. It's generated by the NDK. It's initial it's called the native development kit. The NDK it's installed in the mobile SD Ubuntu virtual machine. So we need to download those. We need to download those code. We need to download those. We need to compile those code in that machine. We need to download those code first. So let's download the instruction and copy the code from there. So those code is not compiled in Recover OS or Android OS, as neither of them has the native code development environment installed. They will not be able to run the C or C++ code. That's why we need to run it, build it at first using the native development kit NDK. Now we have downloaded the folder. We begin to create the file that makes the program to create the app process file that we need. When we build the Android NK file, we see that the local module and the local source file, it's not the file name. We need to put into the put a new. We will need to put the app process.c file that we have created to let Android.mk found it and be able to run it. After accomplish all this, we can run a compile.shell file, which will run the ndk command to make us Android runnable file. We have some issue here. Let's see what is the problem. Oh, it turns out that when I copy the code, there are some words that it's not copied correctly. Let me fix this. In this part, it turns out that the new app process I was spelling wrong here, so you can just feel free to skip this part. It took me a little bit time to find out what the problem is. Okay, now we can see our uh, compile is success. Um, we have generated a new app process file that can be run by Android. Now we need to copy this file into the um, over-the-air package on the end of the Android folder. So this way, when the update script is running, we will be able to run this uh, new app process. We will be able to move the old uh, app process to app process to a backup place and let them to run the app process that we have write, which we can see from the left side in the code. We have in, injected a file. We have opened the file called dummy.2. That also means created the dummy.2 files under the system. Now we need to write the update binary that will run when the system Android OS is being boot up. First of all, we need to move the file, we need to move the original app process file to a new name maybe. Let them uh, leave a copy. Then we need to copy the app process that we have created to where the original app process location of original app process. So later, when they run app process 32, it will run the app process we have wrote. We give this app process 32 runnable permission. Now we can build the OTA package since we have all the code ready. Now we can start this virtual machine and go to the recover OS. Now the OTA package is successfully being given to the recover OS. Now we unzip it and run the update binary file. When we reboot device, that's when we go to the system, we will be able to see the dummy2 file. It's located on the under the system folder. So by 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 showing this, the Android device routing task 2 is completed.